Hey YouTube, and welcome back to the IoT Developer Masterclass. Previously in the last video, we talked about how we can connect ESP32 to the IoT connector platform, and in the previous video before that, we talked about connecting our Raspberry Pi also to the IoT connector platform. Now, in this video, we're just gonna do a kind of quick introduction to the IIoT, which is the Industrial Internet of Things, and it's just a little tiny introduction. Basically, what we're just going to do is we're going to connect a programmable logic controller, which is a PLC, to our IoT connector platform. And again, the platform is the same, nothing's changed in the platform. We're using the same platform. And here in this video right here, you could see what we're talking about, right? So you could see here we have this BRX PLC, right? And this is going to be our gateway that connects. And there are a few, buttons here that control our device and a few LED that shows the state of our device. The green LED tells us it's on. The yellow LED is an indicator for this light bulb. The first blue LED here is for the cooler, which is the top fan. The second blue LED is for the heater, which is for the second fan. There is a thermistor inside this box that measures temperature within the box. So it measures the resistance depending on the heat. So if there's more heat, the resistance of that thermistor changes, and using the Steinhardt equation, we're able to convert that resistance into temperature. And if the temperature is greater than the minimum temperature, we'll trigger on the heater. If the temperature is greater than the maximum temperature, we'll trigger on the cooler. And that's just what's going on here, right? So again, it's pretty much the same as what we've always done. If we go in here and we go to our project that we've created, we go to telemetry, you could see right here that we have data coming in, right? So let's connect to our system. Just make sure we're connected. Connect to our system here. And if everything's connected properly, we should start seeing data, right? So you could see our lamp here is off, right? Which on our, you can see on the in the camera here, it shows the lamp is off, right? And if we were to switch on the lamp, again, we're sending command to that BRX PLC, right? And basically you can see when we send it, the BRX PLC receives that command, processes that JSON data command, and it's able to trigger on that light bulb. And 10 seconds later, we should see that command and the lamp here is on. Again, if we were to maybe trigger off the lamp and we send that command, you can see the lamp has come off, right? And a few seconds later, when it's 10 seconds from the last update, you can see that that lamp now state is now off, right? And again, you could see here also the temperature, right? So you can see here the thermostat is on, and the cool is on. It just went off, right? So basically we could also, like, maybe if we wanted to trigger on the cooler, right, we could let's set the let's say we want to cool the temperature down. So the current temperature is 75.6, right? And the minimum temperature here is 75. So the heater just came on, but we can override that. We can turn the cooler on for about 32 seconds, right? And once we send that, you can see our cooler just came on, right? And now basically our temperature, you should probably see our temperature kind of start coming down from 75.9. So next update should be a little lower than where it was before, right? So it's coming down to 75.95, now it's 75.7. So you can see the temperature. And if we decide, okay, we want to heat it up a little bit, let's heat things up. We can set the heater, and we could set that to on. And once we send the heater command, oh, the heater is already on, right? But we could also set the heater to off. And once we send that, you can see the heater came off. So basically the temperature was probably already lower than the minimum temperature. That's why the heater came on. And now we can just set that from the UI here and override it just for about 32 seconds. That's the way the code is written, and it just comes off, you know. And again, there's other things you could do. You could set your minimum temperature, set your maximum temperature, and then, you know, widen it a little bit, reduce it a little bit, and that affects the system itself, you know. Could be in a factory setting where, you know, you're monitoring this. And we also did some previous exercises before where we use machine learning, so all this data can be routed to machine learning service somewhere, and that machine learning service is understanding data, and based off of that making changes, you know, to that data, and controlling the system how it feels it should do it more efficiently. Normally in this use case, in a real life use case, that machine learning service will probably be local. Latency would be better, you know, if you had it more local within the remote location there. All right, but again, it's just one of those things that you can try out, right? Very simple project. It's basically just an introduction. We've gone through all this before. The only new thing here is just learning ladder logic and how to use it with the BRX Dumo PLC. I really do hope you enjoy these videos. You know, it's pretty cool just, you know, setting these things and just setting the state and just setting things on, sending a command and things just coming off or setting off or setting command. And you can even trigger off the gateway, right? You can set the gateway, set that state to off, and shut off the gateway, and now it's off. The red light is on, right? You'll have to restart that locally here. You can't restart it from the cloud. All right, but basically, this is just an example of the industrial Internet of Things using a PLC, and you know, it's pretty much what we've been doing in the last series of videos. It's the same thing. You just have to learn a different programming language and how to integrate these machines, right? So I really do hope you enjoy this. Please feel free to write, comment, subscribe, and please do share this video. I'd really like some subscriptions, so please subscribe. And now let's get right into it. So in previous videos, we've considered how the ESP32 can connect to our IoT platform. We also looked at how the Raspberry Pi connects to the IoT connector platform to send or receive command data, right? In this video, we will be using the IoT connector platform, the same IoT connector platform that we've built and been using in this video series. However, we would be looking at how we could use it in a more industrial setting. And what that generally involves is using a gateway that we know is used more in industrial settings, like a programmable logic controller, also known as a PLC, and have that gateway send data or receive command data from our IoT connector platform. Now, we wouldn't be making any changes to the IoT connector platform. We want to make sure there is minimal changes as much as possible so that we can just have any gateway or any device out of the box just coded and connecting to our platform and using our platform, right? So what we're gonna do here is make sure that we have a device that can easily connect to our platform. We want to take note that that device should be able to use MQTT to connect to our platform. We also want to make sure that that device can parse JSON data, because our IoT connector, when it sends data down to the gateway device, it sends that data in JSON format. We also want to make sure that that device can also build JSON data and send JSON data to our IoT connector platform, because IoT connector platform is listening for data, but the data it's expecting is a JSON format. Now we also want to make sure that that device can register with our platform, and so in this case, you know, our registration or provisioning service API rather is using a REST HTTP request, right? So in this case, we want to make sure that that gateway device can also make a HTTP request to provision itself or the devices connected to it to our IoT platform. So apart from the fact that I had this PLC lying around, the BRX PLC is also a great PLC too that actually covers all the requirements that we need. It can actually connect to an MQTT broker as a client. and it can send data to the broker or receive data from that broker. It can also read JSON data or send JSON data, build a JSON text data and send that, right? And it also has the ability to make HTTP requests. So there's a lot of PLCs that can do the same thing, but the BRX, I had one BRX PLC lying around, and it's affordable and cheap and can be used in this case. Now, again, there is no change to our IoT platform. Our IoT platform that we're running is the same platform that we've ran in our previous videos. Basically, the BRICS PLC will connect to IoT Hub, right? After provisioning, initially it needs to call an API service, the provisioning service, to provision itself so it can register the devices that are connected to it. Once it's provisioned, it will be given the access keys to be able to connect to the IoT Hub, because without the access key, it will not be able to log in to our IoT Hub, right? Which is essentially an MQTT connection to our RabbitMQ. So it would need the username and password to be able to log into the MQTT and start publishing or subscribing to certain channels. Now, once it publishes data, most likely our telemetry data, we have our event hub that's constantly listening to the telemetry queue on the RabbitMQ, and once there's data on a particular queue, our event hub as a consumer will consume that data and route that data into our MongoDB database. Now, for users who are currently connected to receive real-time data, the event hub will send real-time data to the WebSocket service so that they can actually visualize that data on the dashboard, the IoT connector dashboard. Now, again, this is what we've done all along. This is the same thing we've done from the beginning of these video series, especially as we started using the IoT connector platform. And so there is no change. Now, there's going to be a lot of coding here, especially with the ladder logic programming for PLCs, and we're going to try to go over that. Again, I really hope you enjoyed this video. There's a lot into it. Please feel free to send your questions, and if I have some time, definitely I will be replying to your questions. And now let's get into it. So for this video, we're going to be using DigitalOcean, just like our previous video. And let's go ahead and create our droplet server. Just going to create a new droplet. Select New York, that's fine. I'm also going to, so for the OS image, we're going to use Marketplace because we want Docker installed. So I'm just going to search for Docker. And here is Docker, so I'm just going to select Docker. So this will create an image for a server for us that has Docker 23.06 installed on it, and an Ubuntu 22.04 server. So that's good, should be good for us. So I'm just going to take a basic plan, and let's just take a regular plan, and I'm going to take this 8 gig memory. Should be fine, $48 a month. And then we're just gonna use password for now. So I'm just gonna set my password. And we're just gonna give it a host name. Let's say IoT Masterclass Docker 02. Okay, so I think that's all we need to do. It's in this project, so let's create the droplet. And I'll just wait for it to finish creating. Our droplet is created and it already has Docker installed in it. So what we're gonna do is we're gonna connect to it via SSH. If you've been following the previous videos, you'd know that we use the remote SSH extension, so you can go ahead and install this so that you can connect using remote or remote development, which also installs the remote SSH and other nice tools that you could use. So let's go ahead and go here. We click on this blue icon down here. In some computers it might be green, but just click on it. And once that opens, we can go to connect to host, and we can configure our host, and we just go to the personal settings here, and we'll copy our template out of here, and we'll just paste the template. And for the host name, it could be anything, so we'll just call it Docker IoT Masterclass BRX. For our host name, that will be our IP address, so copy the IP address and we can paste it down here, and our user will be root. And now we can just X out of here. Just make sure you save it first. And now we can X out of here. And now we can go back and connect the current window to the host, and we'll connect to the profile we just created. That's the Docker-IoT Masterclass.brx. We'll select our platform, which is Linux, and we can accept the fingerprint for that. And now let's log into the server. And if we're connected, we should see our login username down here. So yep, we're connected as root user to IoT Masterclass Docker 02. So now let's create a folder called applications. So we just make KDIR applications. That should create an applications folder for us, right? And now let's go ahead and open that folder. So we just go to open folder, applications, okay. We are using a Linux server, right? Yeah. And our password. I'm gonna trust the computer. Yes, I trust the authors. Asking for the password again. And once we log in, we should have our applications folder here, and that should be good. So now that we have all we need here, we're going to go ahead and now download and install our IoT connector. Okay, so let's go here now and copy our connector API. So let's copy this, copy link, and now we'll go to clone git repository. We'll just clone git repository. We'll paste that in. We'll clone from URL, and we'll clone it into applications, and okay, and we just cancel. We want it cloned into here. All right, so now let's do the dashboard. So now we've cloned all three applications. We could just rename them just to make them a little shorter. So we'll call this connector API. So now we have what we need. We now need to install our Docker Compose, right? So basically we need to run these two Docker commands for Docker Compose, but since this is our first time running, we can only run this one. Now, this is our first time, and this is installed using Snap, right? So let's open this in terminal. If we run this, we're gonna get an error because Docker Compose isn't installed by default with Snap. So what we need to run is install Docker Compose. So let's run that. Let's say sudo install Docker Compose. sudo apt install like docker dash compose. Okay, and if that runs correctly, do we want to continue? Yes. And so that should take a while to install. So we'll just choose N for now. Okay, so let's go ahead and install the extension for Docker. It's created by Microsoft, right? And we'll just install that. And now what that does is that should add this here for us. Okay, looks like everything is connected, everything's okay. So let's run this command again. So that's docker dash compose dash dash project dash name equals IoT underscore masterclass space dash F space docker dash compose dot YAML space up dash D. So if we run that, if that runs, that should build everything that we have in the Docker Compose file for the API, which includes the APIs, the MongoDB server, and the RabbitMQ service, right? So that should install, build and install. All of that should take a while, and it should also load it also. Okay, here we go. So all our containers for that IoT connector API have been installed. Let's just make sure RabbitMQ has been fully installed before we install the next things. So RabbitMQ is still running some installations for the plugins, so we just wait for those to complete. Okay, so our RabbitMQ server has been fully installed and it has started. So now let's go ahead and install our Event Hub. So let's open the Event Hub in the terminal and we'll run the same script. So let's run the script and that should build and load up our Event Hub. Let's just make sure Event Hub is coming up. So now we should have our Event Hub service right here, right? So we have the IoT Masterclass Event Hub service, so that's up and running. And now let's just make sure our Event Hub is running correctly. So let's view the logs. So you could see here that our Event Hub is connected. It's connected to the RabbitMQ and it's waiting for messages. Okay, while we're waiting for that, let's install our dashboard. So I think that's the last one we have to do. Open integrated terminal. We're just gonna paste in the same command and run that. Again, if you make any changes in the code, you might want to build it before you run it again. But since this is our first time, we're just gonna deploy, which will build and deploy at the same time. Right, so now we have that running and our dashboard container is up, right? So now we have all our services. So at this point, we are good to go. So let's just make sure we can go to we could just go to our IP address, right? And just type that in and go to that IP address. And if everything's okay, we should have IoT connector. Now, the default username is admin@admin.com. default password should be admin. And once you log in the first time, you should probably change your password. So the next thing we have to do now is to install the code into our PLC. So I'm gonna go ahead and set up my PLC and connect it, and then I'll be back. Before we go ahead and discuss more about the project, let's go and download the code for this PLC. So we're just gonna go back to our IoT developer masterclass repos, and we're going to go to the IIoT BRX PLC gateway, right? And let's talk a little about the circuit before we download the code. So let's go to circuit.jpg. Now, if you look at the circuit, you're gonna see we have a red button, a green button, a yellow button, and a blue button. And essentially, those are connected to the X0, X1, X2, and X3. So now we also have these indicators, the red indicator, green indicator, yellow indicator, blue indicator, and the second blue indicator. So the first blue indicator is actually for the cooling element, which is the fan, and the second indicator here shouldn't be lamp. The second indicator is for the heating element, right? And so what happens is when you press the blue button in the initial state of the blue button, there the blue button when the initial state, the zero state, both the both indicators will be off, which means that the cooling element and the heating element will be off. When you press it the first time, there is a counter that counts, and then if you've pressed it only once, then the cooling element will come on, and on the second press, the cooling element goes off and the heating element comes on. On the third press, it resets back to the initial state where both elements are off. Now you can see here that the blue indicator here is connected to the cooling element, and the second blue indicator here is connected to the heating element, and the yellow indicator here is connected to the lamp. And we have this WX0 for our analog input, and what's going on here is that we are using a thermistor. The thermistor is inside our box, and that thermistor is connected in series with a 10 kilo ohm resistor, and we're using that to measure the temperature using the Steinhardt equation, and we might talk about that later. And so basically, as the heat increases within the box, thermistor resistance changes, and based off of that, we can measure that input value of the resistance within our analog input. So that's just a general overview of our circuit. So now let's just open the box and show what's in it. If I were to open this box, so you could see in the box there that we have a thermistor. It's not very clear, but it's right there in there. You could see it in there, and holding it with a tape, or black tape right there on the side. So you can see there's a thermistor there. And then up here, there are two fans. One is actually for the heater, and the other one is a cooling fan, right? So let me close this back. So this is closed, and I'm just gonna put this on the side so you can see it. So you could see there are two fans right there. There is a small fan on the bottom, and there is a larger fan on the top, right? And both fans, the smaller fan has a heater, so it sucks in air and passes it through that heater and then into the box. And the larger fan is just a cooling fan, so it just blows in cool air into the heater there. Okay, so now let's go ahead and download our code. So what we're gonna do here is let's go to the source right here, and then let's go to, we need to download this code. So let's go to downloads. We'll just go to download repository, and we should have that downloaded. So now let's extract that. And now we have our folder right here. So this is our folder. So let's open it and see what's in it. So essentially we have this code. So what we need to do, our code is a text file. So that's the IoT control. We need to import that and save that into our PLC. So let's go ahead and start with that first. So I'm gonna open my Do More Designer. So here's my Do More Designer. And now let's import our project. So basically we're gonna go to File. We're going to go to Import Project. And we're going to go to, let's just make sure we're in the right file. So it's on my desktop. Let's go with Francis, right? And this should be the file that we just saved. So we're gonna import IIoT control. So let's import that. We could just call this IIoT BRX. Let's import that. So if our import is successful, we should see all the files that we have for this project in here. There are a couple of programs and tasks that are running, going to be running, and we can talk about that later when we're done. However, right now, what we have to do is we already have this opened. So now let's go ahead and connect to our PLC. So we're going to go to PLC, connect, and now we're going to select the PLC. I already have my PLC connected on my network and configured for my network. So I'm just going to connect to it. And then I'm going to override whatever is in the PLC. So I'm going to say go online, view this project, continue online. Now my PLC clock isn't set, so I'm just going to set the clock to make sure it has the correct time. So that should be the correct time right now. Set PLC clock and exit. And I'm just going to click finish. Now we have currently connected to the PLC. We also have set the clock. PLC now is connected to this Do More Designer. Now the next thing we have to do is just save and write this project. So let's save this. Once that's saved, let's write it into the PLC. So we're going to go ahead and download the project into the PLC. Okay. And now everything's okay. Everything's working. Looks like we have written the code into the PLC. And now we're good. Yes, save to disk. At this point now, we've written the code into our PLC. However, there are some environment variables that we need to set up. And so let's take a look at some of these environment variables. So if you go back to our code, you'd see that there is this file here called IIoT memory data.xl. Now we can't open that here. We'll have to open our computer, right? However, there is a image file that we should have that shows the memory map. So there are a couple of settings that we need. We first of all need to set the group ID. If you remember from the previous code, we will have to create a group first so that the gateway knows where it should create its devices, which group it should link its devices to. And then we also need our host name, which we just created. So there's no way our gateway can know that. So we have to kind of upload that into our gateway, right? So let's go ahead and set those up. All right, so first of all, let's open that file. So let's go over here, and this is the IIoT memory data file here. So there are a few things that you should take note of here. So first of all, we need to change dstring 4 and dstring 3. Those are the main two that we would need. This dstring 5 is the override time. Usually that's about 32 seconds, right? And so let's go ahead and change this first. So first of all, we need our IP address. So let's get our IP address. So our IP address from DigitalOcean is this. So we're gonna copy it and we're gonna paste it in here. Now this should be a string, so we're just gonna paste it within the quotes. So that's our URL host name, right? That's that IP address that we just set there. So that's this. Now we need the group ID, right? So basically what we're gonna do is we're gonna go back to IoT connectors, just make sure we're still logged in, right? We're still good. And we create a new group and we'll call it IIoT BRX. The maintenance requires just the group name. So let's just go ahead and create that. So now we have an IIoT BRX group. Let's copy the group ID from here. So we'll just copy this group ID here. And now we will just paste this group ID in here. Let's make sure it's a string, so all strings should be in quotes. And now that we've pasted that in there, I think we are good to go. Yeah, so we just need the group ID and the URL host name. And now once we have this, our import can only support CSV files. Alright, so let's save this as a CSV. So first let's just save this, and now let's save as, and we are going to save this as a CSV file, and we would just save. Now separators for CSV should be comma. Text markers, we just have none for text markers. Encoding, that's fine. I think everything else looks okay. Because we need to make sure that only the strings are in quotes, and we need to make sure nothing else is in quotes apart from what we want to be strings. Alright, so once we do this and say okay, and now we should have our CSV file. So here is our CSV file right here. So now let's open our Do More Designer, and now we would need to import that memory data. So let's go to File, Import Memory Data. Okay, so let's go to Memory Data, CSV, and we'll open that. If it's open correctly, we should have this all configured. So D in 2 is 1, which is saying use the configuration from the CSV instead of using whatever is in the code. And we have D string 4, right? D string 4 is our, so let's just go over this quickly. Let me open the image, memory map image. So D string 4 is our group ID, which is the group we just created. D string 3 is our host name, which is 159.89, right, and all that. So we have that. And then we have our URL port, which is 7000. We have our API key, which was already there by default. You can change it. If you change it in the API, then you have to change it here. And we have the ID for our BRX gateway, which is D string 0, 1, and 2. Those are together, so those have been lined up together there. And then we have the BRX thermostat ID. That's D string 2, okay. Yeah, that's fine. So we have the D string 6, which is our secret key. So our secret key is the password for connecting to the MQTT and RabbitMQ. So if you change that, and whatever key you set is what you're going to be using, your device will need to use, right? So, and then we have D string 3. D string 3 is 10 seconds. So it just tells us that every 10 seconds we can update, right? So publish interval for telemetry, right? And then the int 5 is the override time in microseconds. We're using the temperature sensor, right, as a thermostat. So whenever the temperature is lower than the minimum temperature, it will kick off the heater. And whenever the temperature is higher than the maximum temperature, it will kick off the cooler, right, and switch off the heater. And then whenever it's in between, then it switches both off to maintain the temperature in the box, right? And so once you use the button, you're gonna be pausing the thermostat from actually being in control for that period of time, which currently is set to 32 seconds. So your button only kind of overrides the actions every 32 seconds, right? So now let's go ahead and write this to our PLC. So once we write this, so it says all the writes were completed successfully. So now everything's written into the PLC. Again, just to confirm, if we go here to IoT connector, you can see there are no new devices. All the devices have not yet been set, right? And now let's go ahead and turn on our device. Our device right now is in term mode. The BRX controller is in terminal mode because that's the only mode we can use to write things into it, especially configuration settings. You can write code into it that, when it's like, but when you want to write maybe configuration settings, setting up, the memory blocks and all of that, you need to have it in term mode, right? So now let's put it in the run mode. So I'm just gonna go ahead and do that. So now, putting this in the run mode, you could see that our red indicator is on, which means that our system is still off, right? But the code is running. To put it on, you would need to press on the green button so that the green indicator can come on. That tells you that the system is on. Immediately the system comes on for the first time it comes on, it will register all the devices connected to it, to the IoT connector platform. So you could see here, still we don't have any devices yet because it hasn't come on yet. So let's go ahead and put it on now. So I'm gonna go ahead and press the green button. Now you could see that the green button is now on, and immediately came on the first blue indicator. The green indicator came on, right, which shows that it's on, and the first blue indicator came on, which shows that our cooler is actually running right now, right? And so let's refresh this. Refreshing this, we would see that our gateway has been registered, our lamp also has been registered, and our thermostat has been registered. Now, one of the things we forgot to do here is that our thermostat isn't really known at this point, and you will see what I'm talking about. If you go to telemetry, you would see that our system only sees our lamp, right, for the BRX lamp, for the state and the brightness, and it only sees the gateway. It doesn't understand the thermostat, even though the thermostat is registered. Now, the reason behind that is because the profile for the thermostat isn't known yet to the system. And so even though there's data being published, the profile for the thermostat isn't known. So what we're gonna do is we're gonna go back to profiles and we're gonna create a new profile for thermostat. All right, so we're just gonna go down here, new profile, and let's just go down to the code down here. If you scroll down, you see what we need to create. So we'll have thermostat and thermostat profile. So let's just create that. So, temperature here is a decimal, heat is string, cool is also string. And now let's create this profile. So now that we've created our profile, our thermostat profile, if we go back here, we can see that our okay, so this is our device that has a thermostat profile, and if we go to telemetry, we can see that we now have all the outputs for our thermostat. However, we are not receiving data. Now, the reason that is because there's still one more configuration that we had forgotten to do and we should have done this initially before we switched on our device. Let's stop the device first. Okay, so I pressed the red button, which stopped that. And now what we have to do is we have to go to the PLC and we have to go to the system configuration, right? And then we'll go to device configuration. And now we need to configure our MQTT client. So we just click on the MQTT client, right? So our device ID is already set up for us, right? So the device ID, if you had looked at that, our device ID is D5. That's our BRX gateway ID, right? So that's this gateway ID. So that's D50 and ends with 53B. So that's already set up for us. And the password, which is the password that we wrote in using this, which is our top secret BRX password, that's already set. So if you're gonna change those, you probably want to change that there also. However, our server isn't set, and so that's what we're missing at this point. So what we need to do is we need to copy our server data. That's the IP address for our server. And we need to paste that in here. Now what this does is this ensures that it's connecting to that particular server for our MQTT. And so once we have that configured, and now we click OK. So system configuration has been changed. Yes, we need to write that into the PLC. We might have to go to term mode for that. Let me just make sure. Yeah, so we need to go in the term mode. That's right. So let's set our PLC to the term mode. So I'm gonna stop the program totally and put it in term mode. And now we can write that configuration into the PLC. Now that ensures that we can kind of connect to our MQTT. That's one of the reasons why we picked this BRX Do More PLC, so that because it has the ability to be able to connect to MQTT. Now that this is already set up, let's go ahead and switch this on again. So I'm gonna put this back into run mode, and I'm going to put on the device by pressing the green button. Reload this. So let's go to telemetry, and hopefully now we should start seeing data. Yeah. So you can see now that our data is starting to come in. We've gotten a few pushes already from the thermostat. If we go to the states, we can see the gateway states, the BRX thermostat and the BRX lamp. Those have states, so we can see those there. And now we can connect to our device. Now once we connect, we can see data coming in. Now if you notice, we by default the minimum temperature is set to 69.5 and the max temperature, there is a misconfiguration actually. The min is larger than the max. Might be some issue that I had while I was coding. That's fine. You can always reset that, right? So I'll try to make those changes and update it. But here you can see the max temperature here is lower than the min temperature, which shouldn't be, right? So that's error there. So however, we can set that. So let's just go to the BRX, the BRX thermostat, and we'll go to temperature. Room temperature is roughly around 73, right? So let's put this at 73. So if we want the temperature to be around 73 and we send this, now you can see the light on you can see the fan just came off, right? The fan just went off and the light just went off. Now the reason behind that now is our mean temperature has now been set to 72 and our max temperature has now been set to 74. That means that between 72 and 74, our temperature can lay around that. That's just the feature of using this temperature as a setting. Now we can increase this. So let's say we make this, let's increase this to, instead of 74, let's make this 75, right? And so what would happen is our max temperature would be 76, our mean temperature would be 74, right? So what would happen now is our max temperature is now 76 and our mean temperature is 74. Now if you noticed, the second LED light just came on, which means the heater is now on, and you will start to see the temperature start to go up. Now the temperature, the heater just went off, it means the temperature has hit that 74, so the heater just went off, right? And now basically it's in the range where it's gonna just lay around that temperature, and then whenever it comes back down, then it will trigger on with the heater or the cooler, right? So what we're gonna do, let's increase the minimum temperature to 75.5. So let's say minimum temperature will now be 75.6, 75.6, and maximum temperature is 76. So you would see the heater start to go, the temperature start to go up. It's now at 75. It should be at 75.6 now. Yep, it just went off. And now you would see the cooler come on. So you can see the first light just came on because now the heater is really powerful, so it heated up more than that 75.6, and now it's higher than what it should be. So now the cooling fan just came on, and now you would see that temperature start to come down from 76.39. So you can see it's now coming back down. So again, it's just kind of control, just shows you how so it's not 76 point, okay, so it's not less than 76, it's 75.8, so both are off, so it's within the range where it should be, right? So you can see how this works, very easy to use. Another thing we could do now, we could set the lamp, right? So it came on again, based on the minimum and max temperature that we set, right? So let's set the lamp state and let's put that to on. And once we set that, you can see the lamp just came on, right? So now the lamp is on. And now if we went back to off, oh, okay, I guess I'm blocking I didn't notice it's blocking. And now if we set that to off, so you can see the lamp also just went off. So again, we can set this to on and send that, and we can set that to off and send that, right? So, and you would see the state of the lamp is changing here. It was on and we just set it off, so it takes 10 seconds to send that command, and now it's back to off, right? So again, this is just a very simple code. There's a lot going on here, and we're using the BRX PLC. Again, if we were to use the buttons, right? So let's say we turn on the heater, right? Okay, so I'm going to use the buttons to turn on the heater, and you'd see it uses that 32 seconds that we set by default. So let's go ahead and do that. So to turn on the heater, we'll press the first time, which turns on the cool. You see the fan just came on. You can see that. And then we press again. This is on. You can see that. So now our heater is on, which means our temperature will go up, and it'll go past the max temperature of 76 because we're overriding it with about 32 seconds, and now it's off. It's about 78 or more, depending on when the next 10 seconds will come in, and you'd see that the cooling fan now is on, so it will start bringing the temperature back down to the in between the min and the max. And you could check all this here. If we go down here, sorry, not brightness, let's go to temperature. So you can see all those settings we've been doing, they're all in here, right? And one other thing is we can turn on the lamp. So let's go ahead and turn on the lamp. Okay, so if we were to turn on the lamp with the buttons, right? So let's turn on the yellow lamp with the button. So now the lamp is at off, right? And if we turn this on, you would see now that the lamp here just came on. So again, this is just, simple control using a PLC and connecting the PLC, right? If we were to turn off the gateway, we could do that. So let's first turn off the lamp, state off, send, and that turns off the lamp. And then we can turn off the gateway. The only thing is when you turn off the gateway from the cloud, you can't turn it back on. You would have to use the button from the location here to turn. So I could set the gateway. It's like the heater just came on. Now I could set this and off. So you can see the gateway just went off and the red button came on. All right, so again, this is just a simple use case. That's pretty much it. I really hope you enjoyed this. Please, again, feel free to like, comment, subscribe, and share these videos. And I will see you in the next one. Thank you.